Yes, you can use an 831 divider even though the fixtures are single phase. The 831 divider is a three-phase to single-phase transformer commonly used to power single-phase loads from a three-phase circuit. In this scenario, the 831 divider will power single-phase pole lights from a 480 volts three-phase circuit. The 831 divider will convert the three-phase power to single-phase power, also helping to reduce the voltage drop in the circuit, which then allows the use of smaller wire sizes while reducing the overall installation cost. Think of the 831 divider as a specific type of transformer designed for this purpose. A transformer's basic function is to transfer electrical energy from one circuit to another through electromagnetic induction. It typically consists of two or more coils of wire, called windings, wrapped around a common core. The primary winding is connected to the input voltage source, and the secondary winding is connected to the load. The ratio of the number of turns in the primary winding to the number of turns in the secondary winding determines the voltage transformation ratio. In the case of the 831 divider, it takes three-phase power as input and outputs single-phase power. Three-phase power is an alternating current power system in which three conductors carry alternating currents that are 120 electrical degrees apart. This provides a more efficient and stable power supply compared to single-phase power, especially for heavy loads. Single-phase power, on the other hand, has a single alternating current. Most residential and small commercial applications use single-phase power. The conversion from three-phase to single-phase can be achieved using various methods, including transformers. The 831 divider is specifically designed to perform this conversion efficiently and effectively, addressing the challenges of voltage imbalance and harmonic distortion that can arise when directly connecting single-phase loads to a three-phase system. When connecting single-phase loads to a three-phase system without proper balancing, the load on each phase can become uneven. This imbalance can lead to several problems. Firstly, it can cause voltage imbalances, where the voltage levels on each phase are different. This can negatively impact performance and lifespan of equipment connected to the system. Secondly, it can increase neutral current, which can overload the neutral conductor and potentially cause safety hazards. Thirdly, it can introduce harmonic distortion, which can interfere with sensitive electronic equipment and reduce the overall efficiency of the system. The 831 divider helps to mitigate these problems by distributing the single-phase load evenly across the three phases. It achieves this by using a special transformer winding configuration that ensures each phase is loaded equally. This results in balanced voltages, reduced neutral current, and minimized harmonic distortion. Voltage drop is another critical consideration when designing electrical circuits, especially for long runs of wire or when supplying power to heavy loads. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor. This reduction is due to the resistance of the conductor and the current flowing through it. Excessive voltage drop can cause equipment to malfunction, lights to dim, and motors to run inefficiently. Using an 831 divider can help to reduce voltage drop in a circuit by allowing the use of a higher voltage for the main distribution. In this scenario, a 480 volts three-phase system is used. Higher voltages result in low current for the same amount of power. Lower current reduces the voltage drop in the conductors. Additionally, the 831 divider can be located closer to the single-phase loads, further minimizing the distance the current needs to travel and reducing voltage drop. By reducing voltage drop, the 831 divider helps to ensure that the single-phase pole lights receive the correct voltage, resulting in optimal performance and longer lifespan. Furthermore, using a higher voltage system like 480 volts allows the use of smaller wire sizes for the same load. The ampacity, or current carrying capacity, of a wire is determined by its size and material. Smaller wires have lower ampacity, while larger wires have higher ampacity. The National Electrical Code, or NEC, specifies the allowable ampacity for different wire sizes and insulation types. When designing an electrical circuit, it's essential to select wire sizes that are adequate for the expected load current. If the wire size is too small, it can overheat and potentially cause a fire. By using a 480-volt system and an 831 divider, the current required for the single-phase pole lights is reduced. This allows the use of smaller wire sizes, which can result in significant cost savings, especially for large installations like parking lots with numerous pole lights. The cost of copper or aluminum wire can be a significant portion of the overall installation cost. Smaller wire sizes also make the installation process easier, as the wires are more flexible and easier to handle. In addition to reducing voltage drop and allowing the use of smaller wire sizes, the 831 divider can also improve the overall efficiency of the electrical system. By balancing the load across the three phases and minimizing harmonic distortion, the 831 divider helps to reduce energy losses and improve power quality. Power quality refers to the stability and reliability of the electrical power supply. Poor power quality can lead to equipment malfunction, data loss, and other problems. By using an 831 divider, the power quality for the single-phase pole lights can be improved, resulting in more reliable and efficient operation. When installing an 831 divider, it is crucial to follow all applicable electrical codes and safety regulations. The NEC provides comprehensive guidelines for the installation of electrical equipment, including transformers. It is important to consult the NEC and any local codes to ensure that the installation is safe and compliant. Some key considerations for installing an 831 divider include proper grounding, overcurrent protection, and ventilation. Grounding is essential for providing a safe path for fault currents in the event of a short circuit. Overcurrent protection devices, such as circuit breakers or fuses, are necessary to protect the transformer and the connected loads from overloads and short circuits. Proper ventilation is required to prevent the transformer from overheating. The 831 divider should be installed in a well-ventilated area to allow for adequate cooling. Regular maintenance is also essential for ensuring the long-term reliability of the 831 divider. Maintenance tasks may include inspecting the transformer for damage, tightening connections, and cleaning the enclosure. It is also important to periodically test the transformer to ensure that it is operating properly. The specific maintenance requirements will vary depending on the manufacturer's recommendations and the operating environment. In summary, using an 831 divider to power single-phase pole lights from a 480 volts three-phase circuit offers several advantages. Firstly, reduced voltage drop. Secondly, smaller wire sizes. Thirdly, improved power quality. And fourthly, increased efficiency. By following proper installation and maintenance procedures, the 831 divider can provide a reliable and cost-effective solution for powering single-phase loads from a three-phase system.